Yes, I'm Andreas Lowenstein. I'm advisor to the management of Ascendance for some years now. My background is 35 years of aviation and defense industries in very different functions. I've been starting off with a lot of strategy. I've been in functions like program, like commercial, international development, etc. And lately I was the CEO of a helicopter developing and producing company. I would say all types of aircraft, simply because today we have no viable answer to reduce drastically the CO2 emission, which is necessary and which is equally demanded by the authorities. When you see all electrical aircraft, many projects which looked from outside very promising had to be stopped because battery performance today and tomorrow does not allow to fulfill reasonable missions. Yeah? This is one point. And then when you watch some concrete use cases, it becomes evident. When you take fixed wing aircraft, which is probably the most widespread use of hybrid solutions in future, you can downsize the engine, and thanks to the smaller engines you will have an intrinsic fuel burn which will be reduced for the whole mission and for the whole mission profile. When you take drones, today there are numerous electrical drones flying and some drones with thermal systems. The problem of both is the mission range. And with a hybrid solution, you can, in the same weight envelope, double or triple the range of a mission and therefore make drones much more useful, civil or military. Or when you watch the vertical flight, we see here a very broad opportunity which is coming up because again you can reduce the fuel burn in the critical phases like takeoff and landing, which will enhance the mission profile of an aircraft. And then if you watch new concepts which are enabled by this technology, like for instance the Ascendance RTR system, which is combining the strengths of an aircraft with wing, so horizontal flight with very low fuel burn, and you have the electrical boost system for the vertical takeoff and landing, which will give it an outstandingly low fuel burn. We have a problem to fulfill the 2035 and 2050 targets which are imposed by CORSIA and by the European Union instances. The answers could be electrical, but the battery performance is not sufficient. The answer could be hydrogen, but as you have seen, all major players in the area think that the technology is not mature yet, allowing before 2050 or 60 to fly with this fuel. It's not safe and it cannot be easily transported. And then there's SAF. But SAF production, when you see the build-up of manufacturing resources and installations, is very low. Hybridization is actually a very interesting tool to allow SAF to become more efficient. Why that? Simply because with hybridization you will burn less SAF, which means you will free SAF resources which can then benefit other aircraft. Aircraft should be hybridized because this will allow more aircraft to benefit from SAF resources.